All right, 5.4 part 2. This is where we're going to graph and write the equations of medians. Let's all refresh our memory on what a median is. It's a segment that extends from a vertex to the midpoint of the opposite side. So you have a segment that's starting from a vertex and it's going to the midpoint of the opposite side. So the endpoints of a median are a vertex and a midpoint. So anytime that the segment is going to a midpoint, you're going to be using the midpoint formula. So that's what we're going to do in number 1 to graph the median from vertex C. So we have this is vertex C, and we need to graph a median. The definition is from a vertex to the midpoint of the opposite side. So we've got to calculate this midpoint so that we know exactly where to draw our median. Remember again, midpoint formula on your charts, add the x's and divide by 2, add the y's and divide by 2. So first let's get some coordinates over here of A. A is at 0, 1. And B is at 5, 6, 7. 1, 2, 3, 4, 5. So 7, 5. All right, so let's add those x's together and divide by 2. Add the y's and divide by 2. So 7 divided by 2 is 3.5. 6 divided by 2 is 3. So that's our midpoint right there. We're going to label it R. So we're going to go over 3.5 and up 3. And there is our midpoint R. Now we can accurately graph our median. So it's going to go from a vertex to the midpoint of the opposite side. So from the vertex to the midpoint of the opposite side. There's a median. Now, anytime you find a midpoint, you want to make sure you mark it as so that you know that then RC is indeed your median, because the median goes from a vertex to the midpoint of the opposite side. So that's what we did here. We started in step 2, we started at vertex C, and we extended to the midpoint R, and then we connected them. So we have our median CR. Now we're going to write the equation of this median. First, we're going to find the slope of CR. So again, we're going to count rise over run. We go up 1, 2, 3, 4, 5. So we're going up 5. And we're going backwards 1, 2.5. So backwards 2.5. And you always want to reduce that. So 5 divided by negative 2.5. And what we get is negative 2. Now we're going to use one of the points on the median, R or C. It doesn't matter which one. I'm going to go ahead and use C just because it's nice and pretty and it's not a decimal. So C is at 6, negative 2. So I'm going to go ahead and use 6, negative 2. Now we're going to plug it into the formula. Remember point slope. Again, if you don't remember what it is, it's y minus y1 is equal to the slope times x minus x1, where the x1 and the y1 is the ordered pair that your line is going through. So remember, that's why you can use any line. So y minus the y, it's a double negative, becomes positive, times the slope, x minus the x, you're finished. Now remember, you can also put it in slope-intercept form if you use your calculator in Stat Edit, Stat Calc. To do that, you need any 2 points that are on the line. So remember, C right here is at 6, negative 2. So that's one of the points you can put in your calculator. And remember, here is our 1, 2, 3.5. There's our R. So we already have that as a point as well, that it's over 3.5, up 3. So those are the 2 points you can use. And remember, you put them in your calculator. You hit Stat, you hit Enter for Edit, and then you put those in the L1 and the L2. And remember again, in your calculator, L1, L2, these are the x's and these are the y's. So in your calculator should be 6, negative 2, 3.53. So you're going to put those in. All right, and always double check, make sure your x's are in the right spot, your y's are in the right spot, then you hit stat again. You're going to right arrow over to calculate, then hit number 4, and then just arrow or enter all the way through about 5 times, and it's going to spit back the equation, and the equation is y equals negative 2x plus 10. So very good. That means that our slope is negative 2, and yes, that's what we came up with when we counted, that our slope was negative 2, and here it's telling me that the y-intercept is positive 10, and if this line were to keep going, you can see how positive 10 is a reasonable answer. Now what I want you to do is to try to write the equation of the median from vertex B, pause it, and then come back and check to see if you got it correct. Okay, so the first thing you would need to do, if we're extending from vertex B, then that means this line needs to come down in this direction. So we need to find the midpoint of AC. So we already have the coordinates here. A is at 0, 1, C is at 6, 2. So then we would need to find the midpoint there. So let's add the x's and divide by 2, and then add the y's and divide by 2. So 6 divided by 2 is 3. This is negative 1 divided by 2, which is still just negative half. So there's our midpoint. If we go over 3 and down a half, there's our midpoint, and label it whatever you'd like. So now we know how to draw the median in. We can go from vertex B, and we can extend it to the midpoints of the opposite side that we found. Now we need slope, because remember, I'm not asking, not telling you, I don't care what form you write the equation of the line in. You can use your calculator and do stat edit stat calc, or you can use point slope. I'm going to go ahead and use point slope because all I need is a point and the slope. And look, I already have a point here, and I also have a very good point in B right here that I can also use, because remember B is at 7, 5. So you can use either one of those points. Now we just need to count the slope from our midpoint to B. So we're going to count slope here. So we're going up a little half right there, and then 1, 2, 3, 4, 5. Then we're going to go over 1, 2, 3, 4. So up 5.5 over 4. There we go. So up 5.5 over 4. So that's your slope. And I would go ahead and just put that in the calculator and do 5.5 divided by 4. And what you get back when you reduce it is 1.375. You could also math frac that, math enter, enter. And this is also equivalent to 11 over 8. So technically, you never want to leave a decimal inside of a fraction, so you would want to convert it to either a decimal or then convert it back to your improper fraction to write the equation of the line. So now we have our point and our slope. So we can say y minus the y, so it becomes a positive 0.5 is equal to the slope times x minus the x. All right, now since you have a little bit, the slopes are a little bit of crazy numbers, and you do have, like this half point here, remember you can always do stat edit stat calc. So in stat edit stat calc, you would put point B, which is 7, 5, and then you would put this point here, 3, and then negative 0.5. And then do stat, right arrow over to calculate, hit number 4, enter all the way through, and then it's going to give you the equation of the line in slope-intercept form, and that is y equals 1.375x minus 4.625. So if you did stat, edit, stat, calc, that's the equation you should get there. Now we need to add one little piece to this. So if you would flip it over on the back, and I have a triangle for you to draw. So if you would please to draw this triangle on the back of your paper. Pause it if you need to, and then come back because we're actually going to talk about the lengths of the medians and how they're related. So basically, if we were to look at this median here, OQ, it's broken down into sections. So we have, let's look at this median. If we were to draw it as just a segment, we have OQ. This is O. And this is Q. And you can see right here, it's cut off right there by L. Now, this median is divided into two sections so that the bigger section of the median is twice the length of the smaller section. So basically, this is 2x and this one is x. So if I were to give you, all right, that OL is 10, then you cut that in half and say that LQ is 5. All right, if I give you that RL is 6, then you know the longer section of that median. So see how this is one long median, RM. It's cut that. The little piece is half of the longer piece. So this one would be 12. So think about what if we had expressions that were actually the lengths of the median. So if I told you that this was 3x plus 5, and that this one is 2x, and asked you how would you solve for x, like how would you even set that up? Now remember, you could not say that these pieces are equal because one section, the longer section, is double the length of the little one. So instead, remember, you can't say that they're equal. You have to manipulate one of the pieces. So again, what we're going to do, like we've been doing with the mid segments, is we're going to double the little piece. So to solve here, you actually have to double the little piece before you can set it equal to the whole thing. So once I double the little piece, then I can go ahead and solve. And now I know that x is 5. So kind of what I would need you to take away from this is that the median is cut into two sections. The bigger section is twice the length of the little section. So this whole median is 15. The longer piece is 10. The little piece is 5. This whole thing is 18. It's broken down into pieces 12 and 6. If you have expressions, you have to double the smaller section of the median to set it equal to the whole thing. There you go. That is how lengths of medians are broken into pieces.